Hi, this is Math 8, Unit 7, Lesson 5, Negative Exponents with Powers of 10. Alright, so I always like negative exponents and playing with them. I just thought they were kind of fun. So kind of some examples here of what we did today in class, just to recall. So if you had something like, again, we always do powers of 10. I'm going to work with a different base for today. If I had 7 to the negative 2 power, what that means when I see that negative 2 as an exponent there, I can think about it as a, I think about saying right now it's upstairs and it needs to move downstairs. So if it's a negative 2, it needs to go into the denominator. Okay, so whenever you see a negative exponent, it means it's living in the wrong part of the house. There's the upstairs and the downstairs. If it's on the upstairs floor right now, which this is really like 7 over 1, it means it's in the wrong place and it needs to go down that way over there. So this becomes 1 over 7 squared, which is another way of saying 1 over 7 times 7, which is 49. Okay, just like if I had 7 squared is 7 times 7, and just regular 49. So I could do the 49 part 2 and then move them downstairs in the denominator, or however that makes sense to you, okay? But the key thing though is that you use the base, and then you take that base and you put it downstairs, and you have 7 times 7, then you square it and see what you come up with here. So you're going to mark these equations as being true or false depending upon what they're asking you to do, and see what's true there. So recall all of your exponent rules, right? When I have a 10 to the second times 10 to the third, that becomes 10 to the 2 times 3, or 10 to the, or 2 plus 3, sorry, which is 10 to the 5th. If I have 10 to the second to the third power, then I have 10 to the 2 times 3, which is 10 to the 6th power. Okay, and then we also talked about having, if I had 10 to the second, well, 10 to the third, let's do 10 to the third over 10 to the second, that became 10 to the 3 minus 2 power, or 10 to the first. So those are the things we've talked about so far, and then today we're adding in some negative exponents here. Alright, so we use that for these first 3, because those are the ones that go with your lesson. I'm going to move down over here. It says write as a power of 10 with a single exponent. Here I have 1/10, that's my base, and I have 4 of them. So I could take the base, and I could definitely write it 1 over 10, like so. And that's going to be 1, 2, 3 to the 4th power. Okay, so I could write it like that for sure. That's not a problem. Now they want me to write it as a power of 10 with a single exponent. So what they're really wanting to do is get it back to a base of 10. That's their goal here. So knowing that this is 1 over 10, another way of thinking about 1 over 10 is to think about that as being 10 to the negative 1 power, right? That puts it in the denominator. And I'm still taking that to the 4th power. Now if I multiply those exponents together, I now have 10 to the negative 4th. And that works out as well. Another way of thinking about it is that 1 to the 10th is already 10 to the negative 1st power times 10 to the negative 1st times 10 to the negative 1st times 10 to the negative 1st power. Now when I combine those, if I'm multiplying all these together, I simply add all my negative 1's up, and that gets you a negative 4. So it's another way of thinking about that one right there. Okay. Here we have 1/10 times 1/10 times 1/10 to the 4th power. So again, 1/10 can be written as 10 to the negative 1 times 10 to the negative 1 times 10 to the negative 1 times 10 to the negative 1. All of those to the 4th power. So the first thing I want to do is I want to do what? I want to add those up. So this becomes 10 to the negative 1, 2, 3, 4th power, all to the 4th power. And what do I do when I take an exponent and raise it to another power? I multiply. So that becomes 10 to the negative 4 times 4, which is 10 to the negative 16th power. That's the idea. Okay, I'll let you do C, I'm going to let you do D. Let me take a look at E with you real quick. So E, same bases, so keep the base the same. We're multiplying, so it means we're going to add those together. 7 plus a negative 2. Well, 7 plus a minus 2 is like 7 minus 2, and that simply becomes 7 minus 2 is 5. And that's it with that one. Okay. Alright, and then this one here, I'm not going to solve this one, but here's an example. What if I had 10 to the negative 3rd power to the 7th power? What would I do? I would do 10 to the negative 3 times 7, which is 10 to the 21st power. I'd multiply those together, multiply those together. So that's an example to help you out with that one right there. And finally, our last one, a volume of a cone. Yesterday we did a volume of a cylinder. Today we're looking at a volume of a cone. It has a height of 6. So we know that from here to here, a height of 6 centimeters. And we have a diameter again of 8. So diameter of 8. So diameters are helpful, but not super helpful. What I usually have in my formulas are going to be a radius. So what's the radius? If the diameter is 8, a radius is half of that. Half of 8 is 4. And we're going to leave our answer in terms of pi. So here we go. It's helpful to remember that a cone is what? The volume of a cone is 1/3 of the volume of a cylinder. It's a third of it because we can get 3 cones inside of a cylinder. There's a cone, there's a cone, there's a cone. Think of it kind of like that. Okay? So we have pi, 1/3 pi r squared times h. So we have a third of the cylinder. We have the area of the base. In this case here, here's our area there. And then we have our height. That's the formula for the cone. So we keep it, volume equals 1/3. The pi is going to stay a pi this time. Radius we said is 4, so we'll do 4 squared. And our height is 6. So here you have all the numbers all put together. We are dealing with centimeters again, so it's going to be centimeter to the first, right, for this one here. And it's squaring the radius, so centimeter times centimeter, square the radius, times the centimeter height, all becomes centimeter 1, 2, 3 cubed. So your answer is going to be some number to centimeters cubed. I'm going to let you solve that, and you'll keep it in terms of pi. So keep the pi there, don't worry about changing it. That's it for today. Have a great day, and we'll see you next time.